Alright, good day, student. As you can see, you are given a geometrical problem. In this case, a rectangle and a regular polygon are placed together on a smooth horizontal surface as shown in the figure. So, given that line DK is equals to 144 cm and BC, when joined, will pass through the center O of the circle. A line drawn from O to the edge point E of the rectangle is perpendicular line. If KQ is equals to BQ, find the area of the circle in terms of pi. Hence, what are the length and the width of the rectangle? So let's repeat what is given to us so that we'll be able to understand the concept before solving it. So a rectangle and a regular polygon are placed together on a smooth horizontal surface as shown. This is smooth horizontal surface, which means, as we have seen, given that line DK is 144 cm, and BC, when joined, this is BC, when joined, we pass through the center of the circle O. A line drawn from O, this line drawn from O to E. E is the point of here, where the circle touches the edge of the rectangle. Is perpendicular. The line is perpendicular line. If KQ is equals to BQ, find the area of the circle in terms of pi. Hence, what are the length and the width of the rectangle? So if you understand it, let's clean the board so that we have a space to solve this problem. So the first thing is to understand what is required of you to solve and what is given to you. Once you understand these two concepts, you'll be able to proceed into solving this problem involving geometrical shapes. So let's look into it and then I'll be able to solve it. Alright, looking at the diagram, as we have seen, so let's proceed into solving it. Alright, so let's proceed into solving it. Line DK is given to be 144 cm. We have to make some labeling. So let's go here H and let's go here J. We know that DK is given as 144. So I can remove it so we can have space. Let's join HK. I'm using a free hand. You know this is supposed to be straight line. Alright, so once we have done that, the next thing we have to do is to call here. Let's call here V. I didn't draw it to scale, but when drawn to scale, you will see that triangle DVH is equals to triangle JVK. DVH is equals to triangle JVK. So these are congruent triangles, and for that reason, you have that DV is equals to DK divided by 2. Is the half of this length, half of length of DK. So that will give us 144 divided by 2, and that gives us DV to be equals to 72 cm. So here is 72 cm, here is also 72 cm, 72 cm, 72 cm. So the next thing we have to do is to find this angle that is here. And to do that, we have to consider, we know that for a hexagon, the angle at center sustained by each of the triangle that make, if we draw this line here, you see how many triangle? One, we pass through here. 1, 2, 3, 4, 5, 6. There will be 6 triangles. Each of them will have equal angles at the center. So in that case, angle here, angle DVH will be 360 divided by the number of sides of the regular polygon. In this case, we have 6 sides. 1, 2, 3, 4, 5, 6. This is hexagon. So n is equals to 6. That means 360 divided by 6. And that will give us what? That DVH, angle DVH is equals to 60 degree. So angle here is 60 degree. And since here is 60 degree, this length is equals to this length. That means angle here is 60 degree. And angle here is also 60 degree. So which means triangle DVH. And triangle DVH is equilateral triangle. So that is, since it's equilateral triangle, let's proceed into solving other things that we are needed. So since it's equilateral triangle, what do you know about equilateral triangle? Equilateral triangle, all sides are equal and all included angles are equal, which means that side DH is equals to side, since here is 60, here is 60, here is 60, this implies that DV is equals to HV, and that gives us DH. And this is equals to what? 72 cm. The sides are equal. So, which means DV is equals to HV equals to DH. And that's 72 cm. So now as we are getting the DH, which is the side of the hexagon to the 72 cm, notice that KB is equals to DH. KB is equals to DH because this is regular polygon. And once it's regular polygon, all sides are equal. So that leads us to this side. Now we know that KB is equals to 72 cm. And we are given that KQ is equals to BQ, and that is equals to, we have shown that they are equal. In this case, this will be equals to KB divided by 2, and that will give us 72 divided by 2, and that gives us 36 cm. So in that case, we proceed that KQ is equals to BQ is equals to 36 cm. So once we have gotten that KQ is equals to 36 cm, the other things we have to solve. So let's proceed into solving. Since this is a smooth, we are told that the rectangle and the polygon are placed on a smooth horizontal plane. That means they are of equal horizontal surface. So I can join here. Joining here, this is part of the width of the rectangle. This means here will be 90 degrees. And once we don't do that, I can call this point here L. So that we have to consider triangle. Consider triangle KQL. So we already know that KQ is equal to 36 cm. We need to find this angle here. And we can find the interior angle of a hexagon. Because DK is an angular bisector. Since here is 60 degrees, since DK is angular bisector, here will also be 60 degrees. Or use this formula n minus 2 times 180 divided by n to find this angle JKB. That is the interior angle of the regular hexagon. If you do that, you still get 120. So this angle is equals to 120 degree. Now we have gotten it to be 120 degree. How do we find angle? How do we find angle QL? Angle QL. How do we get angle QL? So we know that the sum of angles in a straight line is equals to 180 degree. So that means that we have to subtract angle JKB from 180 degree, which means 180 degree minus 120 degree, and that gives us 60 degree. So we have gotten angle, this angle here, to be 60 degree. We can move on into solving what we have here. So let's clean here. So we now have gotten that angle KL is equals to 60 degree. Alright, let's look into the triangle as requested. So for that reason, we can now find the length of this rectangle, like the width of this rectangle. So this implies we can use by trigonometry. We can use trigonometry to do that. We have that QL divided by KQ is equals to sin 60 degree. So if you cross multiply, have KL to be equals to KQ sin 60 degree, so that KQ is given at 36, and we know that sin 60 is equals to what? Opposite, which is root 3 divided by the hypotenuse. So that if you do that, you have QL to be equals to 18 root 3 cm. So in that case, you have gotten that. Okay, let me write it here. QL is equals to 18 root 3 cm. Now what next thing we have to do? We can notice that this is a line B, like we are told that BC, when joined, we pass through the center of the circle. So let's join it. We are told that when it is joined, we pass through the center of the circle, and this is a perpendicular line, remember, and a line drawn from the center to the edge. It was given to the edge. So the edge is perpendicular. We are told that this is free hand drawn. Okay, so it's perpendicular as told. Alright, so since here this is just a point touching the circle, this point B, you see it, this point B, let's draw a perpendicular line. It just touches the circle at that point. This is a perpendicular line. So the next thing we have to do here is we have to notice that we can find KL. Can we find KL? Okay, from here we notice that QL, this length, let's call this place M. That point of touching the rectangle, let's call it Z, sorry. We can call it Z. You can call it anything, but let me call it Z at this point. So notice that BZ is equals to QL is equals to 18 root 3 cm. Why is this so? Because this triangle here is equals to this angle here, and this length is equals to this length. This is a similar triangle. Triangle BQZ is equals to triangle KL. Similar triangle. Similar triangles are equal. Similar triangles. So let me put it like this. They are equal. They are similar triangles. But not only that they are similar triangles, they have the same property. Because in this case, KQ, it is given to be equals to, remember, BQ. And from what we have solved all the way, we have it is 36. So it has the same property. So here will be 36. So that when we solve for BZ, we still have to get the value of what we have for QL, which is 18 root 3. What am I saying? I'm trying to tell you that, let's kill him here. I'm trying to prove to you that the length OE, are you seeing OE, which is the radius of the circle? OE is equals to BZ and is equals to QL. This is equal to 36 cm, the radius of the circle, radius R of the circle. Is it not? Is it the radius of the circle? So let's continue. So what do we have? Is equals to not BZ is equals to 18 root 3. 18 root 3, which is the radius of the circle. So we have gotten the radius of the circle. So from here we can solve the first question, which is the area of the circle. Can we? So therefore, the area of the circle, in this case I call it A equal to pi r squared. So this is our pi. We can substitute it 18 root 3 squared multiplying pi. I can put in here. So simplify it. Remember you are asked to leave your answer in terms of pi. So if you do that, have the area of the, which is the first question, the area of the circle. Okay, let me use to be equals to, the area of the circle to be equals to 972 pi cm squared. That is the area of the circle. So the second question is to, you are required to find the length and width of the rectangle. Length and the width of the rectangle. So let's proceed into solving it. Can we? Remember that OE is equals to BZ, and is equals to QL, because this is the radius. Remember, here will also be the radius. This means that this is equals to also BO. Is equals to BO. The radius are equal. So let's clean here. Let's clean this side. So let's proceed into finding the length. Already we have gotten the width, because the width is QL. And we got QL to be 18 root 3. Already we got the width to be equals to 18 root 3 cm. This is equals to QL. So we have solved that. So the next thing is to find the length. So let's find the length from the upper side of the rectangle. So to find the length, we know that BQ is equals to KQ, and already gotten it to be 36. Remember, because the length of this, we got the length of the hexagon is 72. So here is equals to this length is equals to this length. So divide it by 2, you get 36. So BQ is equals to 36. Let me clean here. So we can use that 36 to find this length QZ. Can we find the length QZ? Yes, we can find the length QZ, because we also get that QL. Remember, we got QL, which is the width. QL to be equals to 18√3 cm, and we say that QL is equals to BZ. We have proved it before. They are similar triangle, side of a similar triangle is equals to BZ, because KQ is equals to BQ. So whatever you are doing, you still get the same answer. This 60 degree, here is 60 degree. So the next is to find the value of QZ by Pythagoras. Using Pythagoras theorem, we can find QZ. How that BQ squared is equals to QZ squared plus BZ squared. So we know this to be 36 is equals to QZ squared plus, we know this to be equals to what? QL, which is 18√3 squared. So making QZ the subject, you have 36 squared minus 18√3 squared. Use your calculator to do that. So if you solve it, you have 324. That will give you 324. So find the square root of both sides. Have QZ to be equal to the square root of 324. And when you do that, have 18 cm. So what am I saying? I'm saying that QE is equals to QZ, as we have seen, plus EZ. Is it not? So, and we know that EZ is equals to the radius of the circle. I'm using big R, so it's equals to the radius of the circle, equals to R, the radius of the circle. So from here we have QE to be equals to what? QZ, that gives us 18 plus what we have as the radius. We have the radius to be 18√3. 18√3. So if you want, you can simplify it. You can do what? Simplify it. 18 is common, bring it outside, have 1 plus √3 cm. That is the length of the, length of the triangle. We have gotten the width, so let's write it here. The length is equals to 18 in bracket 1 plus √3 cm, and that is it. Is the length of the rectangle. So that is it. Width and the length. Width is equals to 18√3 and length is 18 in bracket 1 plus √3 cm of the required measurement the rectangle. Alright, if you enjoyed this lesson, all I ask you is to give it a thumb by subscribing to my channel to encourage me to bring more videos for your views. Like and share others will be aware of these free videos I'm giving to you. Click the subscribe button whenever there is new update. You will be the first person to receive it. See you in the next free video. Bye for now.